What's up guys, welcome to the next part of the hack and slash tutorial series. In this video we're going to work on the targeting system. So if I hit tab, which is my target input, you can see that our camera rotates to face the targeted enemy, but our character doesn't. So it's similar to like Nier Automata, where you don't have the character rotate towards the enemy but the camera does. And of course we can stop targeting, we can still target, untarget, same thing. Now also our attacks also rotate towards the enemy, so if we're not even facing the enemy and we attack, our character rotates in that direction. You can change the speed of the camera, change the speed of the rotation. I always tell all of you to always make all your functionalities variable so they can be changed very easily. So if we kill our enemy, as you can see, the camera automatically stops targeting. Now if we try to target a dead enemy, the sphere traces don't even actually detect it, so we can actually save some code and some space and some optimization to not use a multi-sphere trace, instead just use a simple sphere trace. So if you guys want the project files, join me on Patreon, where you can get all the access to the project files and all the code. So without further ado, let's get started. What's up guys, welcome back to the next video for the hack and slash tutorial series. In the last video, we worked on a dummy AI that can receive attacks, but as you can tell, it's kind of hard to actually hit this AI, even with the rotation during root motion animations. Still kind of hard to hit them. And so in this video, we're going to work on the targeting system, so we don't actually have to manually attempt to attack our enemies. The character will automatically rotate towards the enemy and attack. So let's head over to our blueprints and open up our player character. And right here we're gonna make a event graph. We could make an event graph. Let's see, is it tick in here? No. Can we pull a tick? Now we are going to use a tick event. Many developers are going to tell you that the tick is not good. It's probably best to try to update the rotation of the camera using timers, but it's going to get very complicated when working with timers. I'm just going to use a event. I'm going to use the event tick just for simplicity. So right here, we're going to make a new event graph. I'm going to call it targeting, e.g. Since I do believe that the targeting system will be the only event that will use the tick. I don't think any other functionality require the tick. And I believe in my old hack and slash tutorial series, we did have multiple functions or functionality in the tick. For this series, I think we could just simplify all our functionality to just have the tick handle the targeting system. And so, first thing we're going to do is we should always have some sort of control over our tick. It's not good to let the tick run on its own. We should have some sort of way to control what runs and what doesn't. And so, we're going to make a branch and we're going to make a boolean. Call it beam is targeting. And we're going to plug that in. Actually, we're going to also make another called target actor. We're going to make this a actor class object, and we're going to check is valid. We're going to grab the function, and then we're going to make sure that our target actor is valid and we are not targeting, or we should be targeting, so this should be correct. So if we are targeting and our target actor is valid, then we should start having our camera rotate in the correct direction. Next thing you want to do is make another branch here. And so what this branch will do is it will handle distance. So if the player runs too far away from the target, we want the targeting system to automatically unlock itself. So right here, we're going to grab the target actor and we're going to check get distance 2. So we should make that over here. So this should be less than or greater than or equal to, and this would be a variable. Let's make this a variable. Call this max targeting distance. So let's compile this and set a value. So if our character distance is greater than 1,000, then we should unlock the target as well. So I guess we can just make this a less than. So less than. If it's less than 1,000, we could continue to update the camera rotation. But if it becomes false, means that our max target distance is greater than our distance, then we want to clear the targeting system and stop everything. And the next thing we want to do is get our controller. And we want to set control rotation. Plug this in here. So this would be a R interp 2. We're gonna plug this in here. This basically allows us to move our camera in a smooth manner. In delta time, I'm gonna get world delta seconds, and our inter speed would be camera rotation speed. So let's make that a variable. Now our current rotation would be our current controller rotation. So get controller, and get control rotation. And we're gonna straighten all these out. Ouch, that did not work. Let's grab these two and just straighten them out. Just move this up. And our target would be a find look at direction. Find look at rotation, and our start would be get after location, which is our current player location. And then for this, we're going to make do a bit of math here. So we're gonna get our actor location, but instead of getting our players, we're gonna get our target actor. So we're gonna get the target actor's current location, but we're also gonna add some sort of offset to it. So we're gonna subtract. I'm gonna promote this to variable. Call this targeting offset. And so what this offset would do, it will change the actual look at location. Instead of actually looking directly at the enemy, I'm gonna have the targeting system look a bit lower underneath the enemy, so we get that top-down kind of view. We're gonna have an error. Just plug that in. I just want to compile so we can set a value here. I'm gonna start with 30. We can modify that. It's a variable. It's always best to make everything changeable, so you don't have to keep finding the functionality and then having to change it manually. That's why I made a lot of variables here. It's right here. This will set. Alright, so the next thing I'm going to do is make a very small function. So not a variable. We're going to make a function and call it... How do we want to do this? We're going to call it end target. And what this simply will do is it will clear this variable and it will clear the target actor as well. Now I'm also going to make another function. And this function will start the targeting. So start target, and this is where we'll do all our traces. So first thing we're going to do is probably do a sphere trace for objects. We don't need a multi-sphere trace. Typically you just want to target whatever's the closest enemy that you're currently looking at. In this system we won't be handling left and right targeting, as there's a lot more math going on in that. I'm going to try to keep this as simple as possible. So our start location will be our camera location. So to get our camera location, I want to get controller, and then want to get control rotation. Or location, get control location. Maybe we can't get the location. That's alright. We can just pull the follow camera and then get world location from here. I was hoping we can do that, but maybe we couldn't. That's alright. So that's it. Now the next thing we're going to do is do a bit of math here for the end. So we're going to multiply, and then we need to add. So we need to grab follow camera, just a variable, and want to get forward vector. And so this forward vector is a unit vector, so which means it's going to be clamped at 0 to 1. And so we want to multiply that by some value to get a distance, and then we add that to our location, and that'll give us the correct position. So this is just a direction. We multiply by distance and we add it to whatever location. It's a bit of math, but it's very useful. Right here. So this, we can actually make a float. So convert that to a float, and we're going to promote this to variable called targeting distance. And I want to make the targeting distance 1000. So right here for object types, we're going to make array. This is going to be pawn. For radius, you can make a variable, but typically it's the same throughout. If you want, you can make it a variable. It's easy to change. I'm going to leave some spots where you can actually do that for yourself, or think for yourself and decide when you need it and when you might not. So I'm going to make the radius 100 for now. Right here, I'm going to make a branch. And on hit, we're going to get hit results, or break hit results. We're going to grab the hit actor and we're going to check is valid. Let's make it the other one, is valid, the macro. Grab the is valid macro, and then from that, we're going to cast it. We're going to cast it to base enemy, so every one of our enemy will always be a child class of our base enemy. So if we cast our parent class, if it works, then that means it's an enemy. It's very simple. You can use interfaces. If you have interfaces, that's what I highly recommend you do, but I'm trying to keep this very simple. So if it is an enemy, we're actually going to promote this, or actually we can just set our target actor. We have a target actor. We're going to set that. Now, once we set it, you want to start targeting. Now, right here, it's probably, yeah, right here, if we don't hit anything, or if the actor is not valid, we should probably clear. I don't think this would ever get called, but just to be safe. Nice. So now let's make an input action so we can get this thing actually working. So let's make a go into input, make an input action. I'm gonna make a pressed trigger, so pressed, and then inside our input mapping, we're gonna add it. Target right here. I'm gonna bind it to tab. So right here in the same exact event graph, so our targeting event graph, we're going to pull off and get our input action target. So on triggered, we're going to do a flip-flop. Now typically I don't like flip-flop, I'm actually going to change that. So right here, I'm going to actually do a not boolean on my targeting. So if we are not targeting, then we should target. If we are targeting, we should end the target. So right here, on this true, we should start target. And on the end, we should end target on the false. So. Now I'm just gonna make this debug thing visible for now, just so we can see what we're doing. So hit play. Oh, that is pretty far. Might actually want to drop the range here. Let's turn distance, drop that down to 500. Make this max distance 800. Radius, let's pop that up. Yeah. What is going on? Is our direction off? No, our direction is right. As you can see, there's a bit of snapping there. I kind of like snap into the target. So let me see. Our rotation, that's why. We did not set our camera rotation speed. So that's why I was kind of snapping to that target. That is weird. I am looking at this target. Why did it go over there? Okay. I hit something, but it's not triggering it. Now it is. Let's see. Let's give this, open up the debugger. Seems like there's some issues here. So if I hit the target, I feel like the math here is a bit wrong. Let's make this 100 for now. Let's make this like 50 just so I can see it. Because I feel like something is very, very off. Why is it drawing so far? Can you just set this 10? Ah, that's why, because we're multiplying. My bad. We should be adding. That's probably why something didn't look right. Alright. There you go. That should fix this issue. So let's bump this up to 500 again. There you go. That's a lot. Yes, that's a lot better. Let's put this back up to 1,000. Make our max distance 1,500. There you go. Okay, now let's change this back up. Let's pick this 150 again. And up here in the tick, in our targeting event graph, right here, I'm gonna make a print string. Just gonna say failed or too far. It's gonna be an error, too far targeting. Target output too far. And then we're going to make this duration of 10. Give it a color of red. Turn everything down. Yep. And then we should end the target here. So end target. And then we should do that on right here as well. Just so we don't get any other issues. Because now I think that should do the trick. There you go. There you go. So now our camera rotates. If I hit tab again, stops targeting. Now let's check if it automatically untargets itself. Yep, it says target too far. Now earlier you saw that my camera or my mouse, I can still move my mouse and my camera still moves. We're going to fix that in 1 second. I kind of want to bump up this distance again. Don't really like how short that is. That should do the trick. Much better. Now to fix the camera issue, let's go back to our main event graph and find our camera. It's movement and then right here. I like this advanced input. It's a lot better than having multiple events for this. We just need a branch and just search grab our targeting and say not. So we cannot move our camera when we are targeting. Now on the false pin, if you want to work with left-right targeting, on the false pin you can do all your math and whatnot you need to switch targets, but I'm not going to cover that in this video as it's going to be quite complicated. Alright, now we should not be able to move our camera once we target. No. So I'm gonna might want to up that off scale a little bit. Up to 50. Much better. Maybe drop that down to 40. Let me see my camera boom. Yeah, that should be a good value. Just have a feeling that my camera boom gets smaller. Okay, there you go. Now the next thing I want to do is have our character rotate towards the enemy. So let's do that. We could make the functionality in here because we're going to use some timelines, but I think we should be fine just using it here. So let's do that here. Put int, name this on. Okay, so right here we're gonna make an event. So custom event called rotate to target. First thing we're gonna do, make a branch, and we're gonna check our target after validation. So right here is valid. If you want to use a macro, you can. Just kind of like using the branch. Right here, we're gonna make a timeline. So let's make a new timeline. Call this rotation target timeline, and we should play from start. Right here in our length, maybe 1.15. So 0.15 might be a good number. Got a float track. Call this alpha. Let's make 2 points. This one would be 0. Start at 0, 0, and then we should end at 0.15, and our value should be at 1. Alright, now on our targeting here, one thing I want to do is actually stop our timeline. So when you make timelines, you actually get a timeline component. That's just how this whole thing works under the hood. So if you do C++, you'll understand why you get this variable, but we could just simply stop. Instead of making another event and then plugging it in here, we just simply call the stop function on the timeline component. It's very useful. So what we want to do is, if we do decide to start playing it, we should stop the timeline before we play it again. But I think that if we play from start, whatever we are on here, we just snap back to it. I think that's just how it works. But stopping it won't hurt either. Right here, we're gonna set after rotation. Here, we're gonna find lookout direction. Find lookout rotation. And actually, we want to check something else. Branch. We also want to check validation here as well. So is valid. So if it is valid, we continue to play. If not, we're going to grab that component again, called stop. Let's come out of here. Start location, get after location. Our target would be our target actor. Get after location. And right here, we're actually not going to plug this in yet. We're going to need to do some other extra stuff. Now, one thing I want to check is making sure. So we only want to change this value here, which is our yaw. And our yaw is our z. But I'm pretty sure this tells us. Right here, yep. So we want to change our yaw. We want to make vector rotator. Plug this into the z. And then everything else should be the same. After rotation. And then everything for our current actor rotation should be the same. So, like so. Plug that in. Very nice. So next thing we're gonna do is we're actually gonna make an anim notify, so we can call this in the animation itself. Or if you'd like, you can just call it in the attack event. So right here, perform attack, you just call it right before you play the animation. But I want to make an anim notify. Right here, doing this, rotation to target. Receive notify. I'm gonna delete this and call rotation target. Rotate to target. Take us to this event. And we're gonna find some of our attack animations. Assets, animations. Could you just grab them from here? Attack, flat attack. It's easier this way. And we're going to make another track. Find our anim notify state, rotation target. So right before attack, we should rotate to our enemy. Same thing. Rotate to target. Right here. Let's copy this so we don't have to keep looking for it. Nice, so let's give this a try, see if it works. Instead of like looking in this direction, see, character rotates that direction. So it works. Now another thing is you can kind of see that rotation, it's kind of rough. So let's see if we can modify this a little bit. Actually, we're missing something. Hold on. Targeting. We forgot a lerp or a rotation. So hold on, let's make like an R rotate 2. Interp 2. Should be our target. Get our rotation. This should be our current. Get up to seconds. And then we can promote this to a variable. Actually, we have an interp right here. Here we go. See how that looks. That might help it. The timing is still quite short. Let's push this back to 0.25. Make our length 0.25. See that? There we go. It's a lot smoother in a way. Let's try lerp. Because our interp kind of feels like it's snapping. So let's try lerp here. So you don't need, we can keep that for now. But let's see how this looks. There we go, it's a lot better. Much better. So let's do a lerp node instead. And let's change this back to 0.15. 0.15. 0.15. So let's give this a go. Yep. Now another thing is that our rotation for our root motion is still being called. So what we're gonna do here, since we already cast to our player character, we're gonna grab our is targeting node, and we're gonna make a branch here. So only if we are not targeting, so we're gonna make a not boolean. Only if we are not targeting should we actually enable this. For the end, we can just always disable it, no big deal. For here, on our false, just make a return. And that should help with that. Yep, so our rotation for root motion and notify state is not running, and our character rotates to our enemy. So that's working. Now the next thing is to have our heavy attacks do the same. So I also have 4-hit heavy attack. So let's add our notify. Now there's this weird bug with Unreal, how you can't copy or copy multiple notifies. I find that sometimes works, but mostly it doesn't. You're gonna get a crash. So it's better safe to just re-look for it and then copy it again just to be sure. Paste that here. Nice. Now we also have our combo systems. So right here in our combo, we have our starters and extenders. Now combo extenders. Right there. I think this one has a 2-part to it, so it's better if we just add 2. So however many attacks that one animation has, probably best to have multiple, unless it's like this spin attack, we just have one. If the enemy dodges or something, we shouldn't be rotating it still. So let's do it like that. That should be good for now. So let's see, everything should be functioning as normal. Yep. Okay, Now one thing I want to do is make sure during our reset state, so let's head back to our main event graph. During our reset state, what's this? Buffer event. Okay, let's pull that up. During our reset state, we should also stop our timeline for this. So we have multiple timelines, so let's make an event for this if I haven't already. Have I? Let's see, set, reset, stop buffer. So no, I have not. So let's make a function called reset timelines. Basically, we're just gonna stop all our timelines here. So stop buffer. Similarly, if you want, you can make events for the stops, or you can just pull the component and just call stop. Either way works. So we're just gonna straighten all those out. In our main event graph, we're gonna actually call our reset timelines, just so whenever the reset state notify gets called, everything just gets cleared, including our timelines. Now another thing is probably that if the enemy dies, we do not stop targeting. Also, there's some things, yeah, as you can see, we don't stop targeting. So that's another thing we're gonna work on right now. Let's pull up our enemy. Just want to make sure that we actually have like some sort of variable that we can pull from it. It's probably best to use notifies, but let's see, or interfaces. Let's see, stats, death, health, stats, current state. Okay, so I guess we can just pull the current state and see if it's dead. That works as well. So let's grab our targeting. In our start, want to cast our enemy. Next thing we want to do is get current state. I want to check not equal to enum. Make sure we're not equal to death. Branch. So if you're not equal to death, we should start targeting. So just so you know, enemies that are still in the world, they can still be hit by our targeting system. So it's best if we ignore those. In this particular one, or in this particular instance, it's probably best to use a multi, so you can actually loop through all your enemies and see who's alive and then target the one that is alive instead of the one that's dead. You can do that. It's pretty simple. Just change this for a multi, do a for each loop, and then just plug in this functionality in and stop it whenever you find a valid target. But for now, just trying to keep this very simple without any major bugs. We're just going to keep it like this. Another thing you can do is actually disable all your collisions for the enemy so that the trace actually just misses it. I'm going to actually test that in just a moment, see if it actually does still hit. For now, let's just add this little precaution for now. So in here, we also need to add that to the tick event in our event graph as well. So if it does become invalid, or if he is dead, we should just automatically untarget him. Doesn't sound right to keep targeting. Let's pull this back a little bit more. And then plug this in. Extend this out a little bit. It's quite a big event. You can probably just collapse this onto an event or a function. I think it would work still. But for now, just gonna keep that. I'm gonna end target. This whole bunch thing. Check. Nice. So let's give it a shot one more time. Oh, that's an error. No, we didn't give it an object. Get our target actor. Plug that in. There you go. Now let's give this a roll. So he dies. Still gonna have to fix up the enemy in just our next couple of videos. As you can see, it's currently dead. Let's see if it actually still targets. So it does actually hit the enemy. So maybe we don't need a multi-sphere trace, as our single sphere trace don't even hit or don't even detect a dead enemy. So we should be fine with just a normal sphere trace. Now this would be our rotation to target. Now, just one last thing, we should clean up our variables and functions. So this should be targeting. Plug everything in. hit actors, targeting, let's plug this in, targeting. Awesome, so everything seems to be working. Now if we close all our tabs, now let's check all our other functionality, our targeting and untargeting. Target works, untarget works. Okay, if we kill our enemy, or if we hit our enemy, so if we attack and then just untarget midway, hit escape, nope, not a single error, so everything seems to be working. I'll see you guys in the next one, and where we'll start working our soft lock system. It's going to be a bit of an expansion to our targeting system, but it's going to be a lot of work, but I'll see you guys in the next one.